All right, welcome back, everybody. In this video, we're going to be working on an example. All right. So I want to know if my coin is fair. And actually, I forgot to grab a coin. I want to know if my coin is fair. All right. I'll toss it 20 times and see how many heads and how many tails I get. Now, what's the null hypothesis here? What do you think the null hypothesis should be? And specifically, should we use a equal proportions null hypothesis or a known population null hypothesis? All right. And in this case, we're checking to see if the coin is fair. So we should use fair as that null hypothesis. So we should say equal proportions. So I'm going to go with 50-50. All right. 50-50 is our null hypothesis that the coin is fair. Now, using that null hypothesis, what should we assume is our expected frequencies if we toss the coin 20 times? What's our expected frequencies? Well, there's two ways to do this. One of them is to just say, all right, 50-50, so what's half of 20? All right, and the answer you get is 10. So 10 and 10. But what I want you to know is you actually just did the exact math that we're supposed to do. Half of, and half is 50%, so half, that's where you got that from, of, whenever you say of, that means multiplication, 20. 1 over 2 times 20 is 20 over 2, which is 10 over 1. So 10. All right, so you actually knew the formula, you just didn't know you knew it. All right, so we've got our expected frequencies now of 10 and 10. Now, what are our observed frequencies? Well, let's try it out. All right, heads. Tails. Heads. If this comes out even, I'm going to be so angry. Heads. Oh, we're doing good. Maybe we can see if this is a unfair coin. Dang it, it's tails. All right. Come on, let's get a few more tails. Tails, tails. Nice. I'm just going to have to lie. Well, that was heads, but I'm gonna pretend it was tails for the purposes of this example. This is a very good way to show how, statistically speaking, the most likely thing to happen is that it would be 10 and 10, which is why that's the expected frequency. But let's just pretend it was 11 and 9, okay? So let's say that our observed frequencies are 9 heads and 11 tails, okay? Oh, I gotta make some room. All right, so first I want you to calculate your chi-squared, and I also want you to calculate your degrees of freedom, all right? Go ahead and try it. It's good practice. All right. Now I'm gonna try. Okay, so I've got my formula over here. Actually, I think I've got this one over here. Degrees of freedom's easier. Degrees of freedom is 2 minus 1 equals 1. All right, so same critical value as last time. Chi-squared is going to be a little bit more difficult. All right, so first we start with our first observed frequency. So that was for heads. And that observed frequency was 9 minus 10 squared over expected frequency, which was 10. And we're doing the sum of, so we'll add that to 11 was our observed frequency for tails, minus 10 squared divided by 10. Okay, So 9 minus 10 is negative 1 squared is 1. 1 over 10 plus another 1 over 10. So we get 2 over 10 total, which is 0.2. All right? So I had 9 heads, 10 tails, 11 tails. Our chi-squared value was 0.2. Our chi-squared critical, you know what, I actually don't remember what it was, so let's go check it out. It is 3.841. 3.841, okay? Now, honestly, we didn't really need to check that because that is a teeny tiny chi-squared value. It's not anywhere near this chi-squared critical value because 9 to 11 is really only one flip off, right? We would need to get quite a bit farther to believe that this is a coin that's not working, an unfair coin, all right? So what did we find, all right? What is our conclusion? What did we learn from this test, all right? If you told somebody, hey, I'm going to test whether this coin is fair. Flip, 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 9 and 11. I got my chi-squared value. I got my chi-squared critical value. What do you tell somebody like as your results? They say, hey, what'd you find? The coin seems to be fair, all right? We don't have any evidence that this coin is unfair, okay? So if our chi-squared value was greater than the critical value, it wasn't, but if it was, then our p-value would be less than 0.05. That means there's less than a 5% chance of that happening based on the null hypothesis. So this means we probably wouldn't have found this weird of a score with a fair coin, all right? If the coin was fair, we probably would not get a chi-squared value greater than the critical value, all right? And we didn't because we had a fair coin. So it worked, all right? About 5% of the time though, even with a fair coin, about 5% of the time, we're still gonna get a significant value, all right? And we'll be wrong, but only 5% of the time. Now, if our chi-squared value was less than the critical value, which it was much closer to 0, then our p-value is greater than 0.05. That means there is greater than a 5% chance that we would get a score like that based on the null hypothesis. In this case, it was way higher than 5%, okay? This means we found reasonable observed values for a fair coin. Yeah, 9 and 11 are totally reasonable to get from a fair coin. Even 8 and 12 are reasonable from a fair coin. 7 and 13, you get a little bit closer. You start pushing it a little bit more. In fact, we've got a little bit of extra time here. So maybe I'll just calculate the chi-squared for 7 and 13, okay? So our frequencies expected were 10 and 10. And our frequency observed in that case would be 7 and 13. I'm not sure if this is actually going to be significant. It's not that far off, all right? So we've got 7 is our observed frequency minus 10 squared over 10. And 13 minus 10 squared over 10 is 3 squared is 9 for both of them. 9 over 10 plus 9 over 10. So that's not even 2. That's 1 point something. I don't know, 1.8. So even that doesn't get us close enough to say this is an unfair coin. All right. At the end of this video, I'm going to try to calculate how many tails we would need, how many unbalanced tails we would need to get this answer to work out to be significant. All right. But for now, let's not worry about it. So what's our conclusion? Well, we ran a chi-squared goodness of fit test to test whether a coin was fair. So when we're doing our conclusions, we always want to start with what kind of test we ran, all right? And we wanted to test whether a coin was fair. In other words, whether it had a 50-50 odds. And found that the flips were not significantly different than even odds. Yeah, it seems reasonable. Chi-squared with degrees of freedom 1 and sample size of 20 equals 0.2. And our p-value was greater than 0.05 because that's a totally reasonable chi-squared value to get. That's a very small chi-squared value. There is no suggestion that there's a difference between heads and tails here. All right. So that's all for part 3. But I really want to figure out this. I really want to figure out how many heads and tails we would need in order to say that the coin is not fair. So I'm going to try 6 and 14. Our frequency expected, as always, is 10 and 10. Let's say our frequency observed was 6 and 14. All right, so I'm pushing it just a little bit further. Now here, we have to remember our chi-squared formula. Sum of frequency observed minus frequency expected squared divided by frequency expected, okay? So that'll be 6 minus 14, 6 minus 10 squared over 10 plus 14 minus 10 squared over 10. So that's 4 squared, so 16 over 10 plus another 4 squared, 16 over 10. That would be 32 over 10, so only 3.2. So that even 6 and 10 is not big enough. Is not a big enough difference. But I have a hunch that if we move our frequency observed one more step further, that's going to do it. All right, so let me check it out. Oh, by the way, you can leave. You don't have to watch this. If you are also going through this process with me, I'm happy to continue, but you can feel free to leave. All right, so let's try it. 5 minus 10 squared over 10 plus 15 minus 10 squared over 10 equals, so 5 minus 10 is 5, squared is 25. Yep, that's going to do it. So that's 50 over 10, which is the same thing as 5, all right? So we finally found a critical value far enough away from 0 that we would find a significant difference. So in order for us to say that a coin was not fair, we would need to, with 20 flips, we would need to find only 5 heads and 15 tails, or 5 tails and 15 heads, all right? Which, that's a pretty lopsided coin, all right? And that's because, you know, we want to be conservative. We want to make sure we're only rejecting the null hypothesis if we're pretty damn sure, all right? And with 50-50 odds, it's hard to make that clear, all right? For those of you who stayed with me to the end there, good for you. You really muscled through that, all right? Next time, we're going to work on part 4, which is the test for independence, all right? I'll see you then.